In step 2 of Z or T tests, we need to state the hypotheses. Now, we're going to continue with the same examples of the Prevnar and the polio vaccine. We've already done step 1. Right? We have the Z tests passed all 3 checks and it has been verified. So now we have to do what's called the null hypothesis. This is our starting point for all tests of significance. And what it looks like symbolically, H sub 0 is null hypothesis. And what this is going to say is that really there is no significant difference. So the way we write that is we have our sample proportion, right, these 710 randomly selected children, is really not significantly different, not statistically significantly different than the population proportion, which in this case is our 15%. So we're saying they're the same, they're equal. So we can calculate what that proportion is, 17, and this sort of absolute number that we are using as our point of reference, which is 15%. What we're really saying is that statistically they're the same, and that the difference is only due to expected random variation that we know always exists. So we can do that with the Salk vaccine also, except now this looks a little different because this is 2 sample. Notice that this was 1 sample being compared against an absolute benchmark of 15%, which we consider sort of our population in this case. Here we have 2 samples, and we're seeing is there a difference between the 2 samples, and our null hypothesis, our beginning point, is no, there isn't. They're statistically equal. You can calculate the 2 proportions. They're different numbers, but again, what we're saying is that they are statistically equal. The difference between the numbers is due to normal and expected random variation, and that's all. There's another way of writing that, which would be to subtract the 2. Of course, if proportion 1 and proportion 2, sample proportion 1, sample proportion 2 were statistically equal, subtracting them should equal 0. Right? So this is another way of writing the null hypothesis when you have 2 samples. Now, we're not done with just the null hypothesis. Right? We have another hypothesis, which is called the alternate hypothesis, which is if the null hypothesis turns out to be false, to be incorrect, what's our alternate? This has to do with one tail and two tail, really. With this one, we're looking for evidence of more than 15%. So we look at what our alternatives are. And they're pretty much always the same. If it's not equal, then either the sample proportion is bigger, the sample proportion is less, or they're simply not equal, which would be kind of the two-tail. It could be on either side. In this case, we're of course looking for more, which would be that, and that would be our alternate hypothesis, H sub A, alternate. We can come over here, do the same kind of thing, where the difference is either bigger than 0, less than 0, or simply not equal to 0, which is the two-tail situation. And in this case, of course, we're interested in if the vaccine lowers the chance, so the alternate would be less than 0. And that's our alternate hypothesis, which both are one-tail alternatives.